Continuing from our last example, we'll continue our discussion on balancing chemical reactions. Now, in this case, what we are having here is you are going to be observing that we have polyatomic atoms. What do we classify as polyatomic atoms? You will see atoms that are together on the reactant side and they are still together on the product side. That's what we call polyatomic atoms. So to make your work easier, you count them as one thing. You don't separate them. An example is if somebody is balancing this first reaction, calcium sulfate and sodium nitrate, somebody can be counting different atoms. Count calcium, count sulfur, count oxygen separately, then sodium, nitrogen, and oxygen. Yes, you can do that, but it's going to be a bit more stressful. So to save that time, all you just do, you observe on the product side and the reactant side, you have SO4 together. So take it as one thing. Same thing, you have NO3 on the product and reactant side together. Take it as one thing. So in my counting, I'm going to do this now. It's going to be, I'll be counting calcium. I'm counting this together. That's what you mean by polyatomic atom. Counting sulfur. And I'll be counting nitrates. Same thing on the product side, exactly the same thing. Sulfate, sodium, and nitrates. So that's exactly what you do in this case. So now, as usual, it's all about counting. How much sulfur, or sulfate, sorry, in this case, do we have on both sides and all the others? So in this case, we have one calcium on the reactant side. Sulfate, taking it as a whole, we have one. Sodium, we have one. Nitrates, we have one. On the product side, we have just one calcium. Remember, this subscript affects only what it is directly in front of. And you can see the brackets here. That means it's affecting only the nitrates. So we still have just one calcium. We have one sulfate. We have two atoms of sodium, Na2. And then we have two atoms of nitrates. You can see if you're counting separately, you'd have said we had 7 atoms of oxygen here. Then here we have 2 times 3, that's 6. Plus this we have 10. Then you start balancing them separately. But since they appear as polyatomic atoms, just take them together. And you see the easy work that comes as a result. Now calcium is 1, balanced. We leave that alone. Sulfate is balanced. We need to balance sodium. Again, we have to make the smaller one become the bigger one. So how do I do that? Multiply 1 by 2. And that gives me 2. What did I do? I multiplied sodium on the reactant side by 2. So I simply come to where I have sodium on the reactant side. And I place a 2 there. Now I recount. Remember, to make your counting easier, it is only the compound that I adjusted, those elements affected, that is what you count. Sodium is now 2, as I've already done. Then our nitrates, remember we're taking it as a single thing, it's now 2. So it's no longer 1. Our nitrate is now 2. This means our reaction is now balanced. You can see how you save the time and the basically energy just in doing this. Now, I got these questions online, but observe something very delicate here. In my previous posts, we have spoken about how to get the proper formula of a compound. If you have not gone through that, go through my previous posts and you'll find them there. Now observe this. Magnesium chloride. This formula is wrong. What does that mean? It simply means that if you try to balance this reaction, there are two options. Either it will not balance. There are some reactions like that because you have gotten wrong formulas. It never balances. Or even if it balances, you are still wrong because this is not the formula for magnesium chloride. Just to show it again, you have magnesium, the valency is 2, and you have chlorine, the valency is 1. When you swap these two, you are going to have Mg, you don't need to write 1, and then you have Cl2. So this should be the correct formula for magnesium chloride. that shows that this is wrong. So that's exactly why we did that first, be able to know how to get the proper formula of compounds. So now we begin to count. There are no polyatomic atoms here. So we have iron, we have chlorine, we have magnesium, and we have oxygen. Remember, we are going to have exactly the same atoms on the product side. So over here, we have iron, we have chlorine, we have magnesium, we have oxygen. So now we count. We have 1 iron on the product side. We have 3 chlorines, 1 magnesium, 1 oxygen. And on the reactant side, for the product side, we have 2 ions. We have 3 oxygen. Chlorine, we have, again, following the correct reaction now, we have 2 chlorine, and then we have 1 magnesium. So you can see, if you have gotten the wrong formula, what you'd have balanced would have been very, very wrong. So now we begin to balance. Iron is 1. To make it 2, we multiply by 2, which gives us 2. So I multiplied iron on the reactant side by 2. So I go to the reactant side, the place where I have iron, I place a 2 there. Remember, what do you need to recount? Only recount the elements affected. So I don't need to come and count magnesium and oxygen again. That's a waste of time. I simply have to count the other element affected, because obviously iron is now 2. The other element affected is chlorine. So chlorine now, 2 times 3, no longer 3. Chlorine is now 6. So now, what has happened? I need to make 2 become 6. How do I do that? By multiplication. I multiply by 3 to give me 6. So I multiplied chlorine on the product side by 3. So I come to where I have chlorine, and I place a 3 there. Again, only recount the elements affected. Chlorine 3 times 2 is now 6. Now we just count magnesium. Magnesium now is 3. No number here means 1. 3 times 1 is 3. So it's no longer 1. It is now 3. So magnesium is 1. I need to make 1 become 3. How do I do that? By multiplication. I simply multiply by 3. 1 times 3 gives me 3. So I multiplied magnesium on the reactant side by 3. So I come to where I have magnesium, and I place by 3 there. Again, the other element affected was oxygen. So I have to count oxygen again. Oxygen now has become 3. 3 times 1, that's 3. So it's no longer 1, it is now 3. And automatically you see that as I was balancing others, oxygen became balanced too. So this is my balanced reaction. So you can see chemical reactions and balancing them is quite simple. Now for our final example. It may look complex, but it's still one and the same thing. So what we have here for our reactants, now again observe, counting polyatomic atoms. You can see we have hydroxide here. It did not appear as hydroxide here. So I'm not going to take it as hydroxide. I'm going to separate them as oxygen and hydrogen. See carbonate here, CO3. Over here, it did not appear as CO3. So it is not a polyatomic atom. I'm going to count it separately as carbon and oxygen. But look at nitrate, NO3. On the reactor side, it appeared as NO3. On the product side, it also appeared as NO3. That means I'll be taking NO3 as a polyatomic atom. So you can see the conditions for taking anything as a polyatomic atom. It must appear the same on both sides of the reaction. If not, take them separately. So I have copper. Hydroxide will not be going together because it did not appear so on the other side. So I'll be taking oxygen separately. I'll be taking hydrogen separately. Same thing for carbonate. I'll be taking carbon separately. I've already taken oxygen, so I don't need to write oxygen again. Then from here, I've already taken hydrogen, so I don't take hydrogen again. But nitrate, NO3, appeared the same on both sides. So I'll take it as a polyatomic atom. So remember again, once I've already done this, what you have on the reactant side, that's exactly what you are going to have on the product side. So on the product side, I'm also going to have copper, I have oxygen, I have hydrogen, carbon, and nitrates. Now you have to watch this very carefully, because the way this can confuse people is this nitrates. Remember, there is also oxygen combined with these nitrates, but I'm not going to count it along with the remaining oxygen. So in some cases, I tell some people, when you want to do this, just remove the nitrates, place it as, say, Y or Z or any alphabet you like. Then when you are done balancing, bring back the nitrate to replace the alphabet. That also works. So that means that you can basically come here, remove NO3 and place Y there. Come here, remove NO3 and place Y there. Then when you are done balancing, bring back your Y. It makes it clearer for you to see. So on the reactant side, I have 2 coppers. For oxygen now, let us count. You can see these 2 affects oxygen and hydrogen, everything inside the brackets. So that means from here, I have 2 oxygens, plus from here, I have 3 oxygens. That means I have 5 oxygens. I will not be counting this one. Why? Because it is part of the nitrates that I am taking as a polyatomic atom. Same thing applies to hydrogen. Hydrogen here, I have 2. These 2 affects the hydrogen, that's 2. Plus, from here, I have 1. So I have a total of 3 hydrogens. Carbon, I have just 1 here. Then nitrates, I have 1. Come over this way. Copper, we have 1. Nitrates, we have 2. Hydrogen, we have 2. Oxygen, there is 1 from water here, 1. Plus, there is 2 from carbon dioxide here, 2. So we have, sorry, I think I'm miscounting this. Should be counting oxygen here. Carbon is just 1. I think we can do that. Carbon is just 1, but oxygen is 1 plus 2. We have 1 from here, and we have 2 from here. So it should be 1 plus 2, and that's equal to 3. All right. Carbon is just 1, as we have it here. Then nitrates, we have 2. So you can see why it's good to go over it again as you are counting. It ensures you're able to delete out any errors. So that's our counting. Then, copper is 1 here, and it's 2 over here. So I have to make 1 become 2. So I come here, and I multiply by 2. That gives me 2. So I multiply copper on the product side by 2. I come to where I have copper, and I place a 2 there. Count only the elements affected, or the atoms affected. So that means it affected nitrates. Nitrate now is no longer 2. 2 times this 2 here, because this 2 affects everything inside the brackets. So I only need to multiply the 2 in front of it. That's 4. That means I now have 4 nitrates. Right? Then remember, any element that appears in 2 sides or in 2 places on the same side of a reaction, that should be the last thing we balance. You can see oxygen appears here, it also appears here. So it's going to be the last thing we are going to balance. Forget about it for now. So even if oxygen takes the second position, we are going to skip that for now. Then the next thing we do, we can choose to balance hydrogen, but if you observe it, it is quite easier to now balance nitrates. So you can see, there's no hard and fast rule to it. You make choices based on what is easier for you. And that's why when you do this, it is easy for you to see what is easier for you to do. So now, making 3 and 2. Making 2 become 3, you are going to be using fractions. It's a bit stressful. So why not balance others first? Then you come back to it. Also, then again, you can see hydrogen appears in 2 places on the same side. Again, that should be part of the last thing that we balance. So there you have it. So now, nitrates, carbon is balanced, so we leave out carbon. Nitrates, is 4 over here, and on the reactant side is 1. So we'll make it become 4. 4 times 1, that gives 4. So I multiplied nitrate on the reactant side by 4. So I simply come here and I place my 4 there. Count only the atoms affected. So hydrogen now is no longer 2 plus 1 to give us 3. Instead, it will now be, we still have 2 from here, that's 2, plus this 4 affect hydrogen, so we have 4 hydrogens here. That means we now have 6 hydrogens. Can you see? Now it is a little bit easier to balance. So we make 2 become 6, multiply by 3 to give 6. So I multiplied hydrogen on the product side by 3. So I come to where I have hydrogen and I place a 3 there. Again, count only the elements affected. On the product side now, the number of oxygens have changed. So we now have 3. Oxygens is now 3, the one from water, plus 2, the one from carbon dioxide, and we have 5. Again, automatically you find out that oxygen has now automatically balanced, and there you have your balanced reaction. Again, like I said, you could have taken this as HY, and this would have been CuY2, taking nitrates and replacing it with Y. Again, remember, Y represents yttrium, another element, but it is the sake of what you are doing here. So once you use Y now, the oxygen will no longer be something that confuses you, just in case you wanted to do that or attempt that. You still get the same answer. Once you are done, come back, remove the Y, and replace it with the nitrate ion which you used. So that's basically